Doing it. All right. Hello, seventh period. This is fifth period. They wanted to say hi to you. Say hi, seventh period. They are all so excited to be here right now, as I'm sure that you are. Hello to our substitute teacher. Thank you for helping out today. I am not going to just be talking to the camera. Sorry, seventh period. I have live people in front of me. This is so weird, isn't it? This is so weird. Okay, I have live people in front of me. Yeah, who knows? There could be somebody, hello to somebody on YouTube who lives, we don't even know where, who doesn't go to our school and might be watching this for help in your geometry class somewhere. I hope that you find the help that you're looking for. All right, so we're going to do a couple of problems today related to these angle pairs that we've learned so far: alternate interior, exterior, corresponding, all that good stuff. I just kind of want you to see what you need to be able to do with these things. So here are a couple of examples of some problems that you might work using these angle pairs. Boom, got it. Okay, so you guys watching at home or in the classroom can still kind of see me a little bit, although that's not going to be very beneficial. You can see what I'm writing here. So first of all, you know, from the very beginning, when we first started in the last chapter, we had those problems that brought like algebra into a geometry problem, right? And so you're still going to see the same kind of things here. Let me just show you real quick what I mean. Okay, so I'm just going to make myself a little diagram here, and you guys can copy this down in your notes as well. And I've got two lines here, and I'm not going to say yet whether those two lines are parallel. We'll get to that in a second. But so far, we just have, you know, this one line crossing through these other ones. And then I'm going to give some algebraic expressions to represent some of these other angles. So first of all, how about this angle right here? And just to make sure that we all know which angle I'm talking about this guy. Okay, see, this is where the colors really help, right? So I'm going to talk about that angle right there. And I'm going to represent that angle with the expression 8x plus 4. You know what I should have done? Why didn't I think of this? Why not just use that same color there? Okay, so that's 8x plus 4. Can you guys see that? 8x plus 4. Okay, cool. So there's that angle. I'll use a darker color for the other one. The other angle that I'm going to do is this guy right here. That green kind of fades into the black a little bit. That green angle is 9x minus 11. So I want you to see what the directions to a problem like this are going to look like, because you do have to think a little bit about what these directions mean and then what you're supposed to be doing. So I'm going to write out the directions just to make sure that we're real clear. So it would say something along the lines of, find the value of x so that, okay, now I'm going to give these lines some names. Let's name them Leonard and Maurice. I don't know why we always use L and M for lines. We just tend to do that. So that L is parallel to M. So we want to find the value of x here that would cause these two lines to be parallel. We don't know if they're parallel yet. We just want to know what value of x would make the lines parallel. In other words, let's say we chose x to be 2. Just pretend that x is 2. If x is 2, how big would the pink angle be? 20. And how big would the green angle be? 7. So if x was 2, this angle would be 20 and this angle would be 7. Okay, hold on to that for a second. In terms of the angle pairs that we've learned, if these lines are parallel, what kind of angles are these? Corresponding. Okay? If these corresponding angles are equal or congruent, then the lines are parallel. Would a value of 2 for x cause my corresponding angles to be equal? No. Would a value of 2 for x cause these lines to be parallel? No. The only way in this case, with the information that we've been given, the only way we can make these lines parallel is by making the corresponding angles equal. So we need to find the value of x that makes these two corresponding angles equal to each other. Now, again, this is not something that I want you to memorize. Like, whenever I see a problem that's got angles with x's and stuff, I just set those things equal to each other. Well, not always. But you got to think a little bit about the relationship here. If these lines are going to be parallel, then these corresponding angles are going to have to be equal. So I need to find the value of x that's going to make those angles equal. So the way I do that is by solving this equation to find the value of x that makes the two angles equal. Now, I'm hoping that algebra-wise, we're pretty good there. I'm going to subtract 9x from both sides. So 8x minus 9x is negative x. I'm going to subtract 4 from both sides. So negative 11 minus 4 is negative 15. Divide by negative 1, I get x is 15. Who has a calculator handy? Maris? Okay, you ready? 8 times 15 plus 4. 124. Anybody but want to guess what she's going to get if she does 9 times 15 minus 11? Do it. Is that what we get? Okay. If x is 15, it makes both of those angles the same. If the corresponding angles are the same, then the lines are parallel. That's your corresponding angles theorem. We wrote that on your pink sheet, remember? Corresponding angles theorem. If corresponding angles are congruent, then the lines are parallel. Okay, that's all that's going on there. So here would be another example. This time I'm going to put what looks like a vertical line. And then here comes 2 other lines across like this. Okay, I'm going to give you 2 angles this time. The first one's going to be this little guy. You know what we call little angles like that are so adorable because they're so little? We call them acute, right? 6x minus 2. Okay, that angle's represented as 6x minus 2. Now, one of these other angles, and it's going to be this guy up here, who's not very acute. What do we call them if they're not cute? Obtuse. That I'm just going to tell you flat out, that guy's 140 degrees. Same directions. Find the value of x so that these 2 lines are parallel. Now, this one's weird because that's not an angle pair that we learned. Those angles are not corresponding. They're not vertical. They're not alternate interior. They're not alternate exterior. They're not same side interior. They're not same side exterior. So we might need to do a little bit of like transitivity here and figure out what the relationship between these 2 angles is. All right, could you figure out another angle that's 140 degrees? Do you see one right next to it? Like go vertical, boom, right? 140 also right across from it. Those are vertical angles. You with me? All right, now, if I look at these 2 guys, those guys are an angle pair. They are same side what? Interior. Thank you. Good job. Those are same side interior. Your theorem says that same side interior angles are not congruent, but supplementary. That's right. They are supplementary. So if these 2 angles are going to be parallel, then my same side interior angles are going to be supplementary, which means if you add them together, you get 180. Now, some of you might have been thinking, like, why not just set 6x minus 2 equal to 40? Like, I know 40 and 140 make 180. And I'm like, that's fine. I'm cool with that. Okay, if you just want to see 6x minus 2 equals 40. Otherwise, I'll do negative 2 plus 40. I'm sorry, negative 2 plus 140, which is 138. So I simplified there. Let's subtract 138. 180 minus 138 is 42. And so 42 divided by 6 is 7. let's just check that real quick. If I do 6 times 7, that's 42, right? And 42 minus 2 is 40. So if x is 7, that angle's 40. 40 and 140 makes 180. Supplementary. Got it? So you got to think about what the relationship is there. Are they congruent? Are they equal to each other? Are they supplementary? Should I add them up and set that equal to 180? Good? Cool? Nice. Next. This next part is pretty easy, but I need to go through it with you anyways. All right, so on your paper here, we're going to make a little diagram, and it's going to be what appears to be 2 sets of parallel lines kind of intersecting each other. It looks like a hashtag, but like on its side. Yeah, so things can get messy. It's kind of what I'm getting at here. Things can get real messy. You can get a whole lot of angles going on. We are going to number these angles. But before I do that, I'm going to name the lines. So we'll go L and M again over here. And then, I don't know, let's just say these other lines are A and B. I know that's not very original, but whatever. Okay, make sure we number these angles the same way. So down here in the bottom left, I'm going to go 1, 2, 3, 4. The bottom right here, I'm going to go 5, 6, 7, 8. I kind of did that differently than I did the first group, but that's okay. In the upper right, I'm going to go 9 and then 10 and 11 and 12. Make sure you number them exactly like I did. I'm realizing now that the way that I numbered them is completely illogical, but that's okay. And then up here is 13, 14, 15, and 16. So 16 different angles going on. Okay, again, I'm going to write out the instructions here just because I want to make sure that I'm being really, really clear. So here's what the directions would look like. Determine which lines, if any, are parallel given the following information. Info. Okay, so I'm going to just give you information about some angles, and then using that information, I want you to be able to tell me which lines are parallel. So the first one would be, if I told you that angle 10 is congruent to angle 13. Okay, so let's suppose 10 and 13 are congruent. Now you need to find those up here. So here's 10 and here's 13. Okay, so here's what's difficult about this. There's 4 lines. In our diagram so far, we've always had 2 parallel lines and a transversal. So this whole situation has a whole extra line going on because we have 4 lines. So what I'd like you to do to make this easier is look at 10 and 13, decide which lines are involved with those angles, and which line is left out. So of those 4, which line has nothing to do with 10 and 13? Yeah, just tell me. M. So I want you to ignore line M. Okay, just ignore line M. Now 10 and 13, somebody raise your hand and tell me what kind of angles 10 and 13 are. Oh, they are cute. Yeah, but angle pairwise. Okay. They are interior for sure. And reverse, I like that you used reverse. I have no problem with that. What, just everybody, what's the other word we use though? Alternate. Alternate interior. So the way that 10 and 13 are alternate interior is if L is the transversal, A and B are the parallel lines. So all we're going to say here is if these alternate interior angles are congruent, that means line A and B have to be parallel. So your answer here would be that A is parallel to B. It's not that difficult. It's just making sense of the mess here. There's just a lot going on, right? Okay. How about if I tell you that angle 1 is congruent to angle 6? I can't see that, sorry. Angle 1's congruent to angle 6. So we can go up here and find 1 and 6. So here's 1, here's 6. Again, figure out which line is not involved. And it seems to me like that line is L, right? L is not involved. Now you can see pretty clearly that, you know, if we're talking about 1 and 6, then these are my parallel lines again. I mean, is that pretty obvious, I think? Which were A and B. Just make sure you recognize that 1 and 6 are alternate exterior angles. Make sure you can see that. They are on alternate sides of the transversal. So M is serving as the transversal here. They're on alternate sides of the transversal. They are on the exterior of your parallel lines. So if 1 and 6 are congruent, then these two lines are parallel. And again, that's A and B. Yeah, so last one, did you guys see what I did? Do you see what I did? Number 1 and then example B. So what would our next one be then? Next one. So I'm going to say angle 2 is congruent to angle 13. So if I tell you that 2 and 13, oh, we're doing 13 again. 13's popular here. That those are congruent. Again, figure out which line's not involved. That would be B. Line B is not involved. So I'm looking at 2 and 3. Can you tell me what kind of angles those are? Corresponding. They are corresponding. And if B is not involved, then my parallel lines have to be these other guys. So that means that L is parallel to M. Okay? That's all there is to it. I just want you to understand what a problem like that means when it's given to you. Is there any questions about that one? All right. So we just took a little break there here in 5th period because we're about to do this proof. 7th period, 5th period out in front of me. If you don't have that copy down yet in your paper, go ahead and do that. This little figure here looks really similar to the one that we just looked at, but I'm only dealing with those 4 interior angles. You might be asking, why did you number them 4, 5, 6, and 7? Why not 1, 2, 3, and 4? I would say, why didn't I number them 7, 13, 19, and 28? I don't know, because that's just the way I did it. The given information is that R and S are parallel. Remember that to show parallel lines, we put those little arrow things like that on them. And angle 5 and angle 6 are congruent. So let's go ahead and mark that on our diagram as well. Our goal here is going to be to prove that L and M are parallel. And we don't know if they are yet. We want to prove that L and M are parallel. I'm going to go ahead and start this time with my given information. We're kind of used to that being the first step. We know it doesn't always have to be. But for this one, let's go ahead and start with both pieces of given information. And our reason there is just that those are given. So we know that S and R are parallel. We know that angle 5 and angle 6 are congruent. Our job is to prove that L and M are parallel. Okay, so here's the thing, guys. I've actually made this simpler than it could be. Oh, Robert, there you go, buddy. I've actually made this simpler than it could be because by numbering these angles, I've given you kind of limited options, which is helpful. I could have numbered every single angle, and that would make it more difficult because you wouldn't have quite as much direction as to like which angles am I supposed to use here. So the idea is if we're going to show that L and M are parallel, think about what kind of angle pair we could possibly have to use to prove that those things are parallel. I'm going to go ahead and tell you it's either 4 and 6 or 5 and 7. Like 4 and 6 are same side interior using lines L and M. 5 and 7 are same side interior using lines L and M. So those two pairs, 4 and 6, and the other pair being 5 and 7, those are the only angle pairs that use line L and M. Hey, you might say 4 and 7, but that's not one of our angle pairs. Okay, so I know that 5 is congruent to 6. I need some way to involve, like to get 4 and 6 together or to get 5 and 7 together. Okay, so we've already got our given statement here. Let's start by just talking about 4 and 5. So here's my thinking. I'm going to come up with a relationship between 4 and 5. And then since 5 and 6 are congruent, whatever relationship 4 and 5 have, 4 and 6 have that same relationship. Okay, but I'm modeling for you right now how I'm thinking about this ahead of time. I'm not just like, well, let's see what happens here. Everybody grab on for the ride. Let's see where this goes. My thinking is, I'm going to start by stating a relationship between 4 and 5. Since 5 and 6 are congruent, whatever relationship 4 and 5 have, 4 and 6 have the same relationship. Okay, so if R and S are parallel, what kind of angles are 4 and 5? Just say it. Just say it. Same side interior. Good job. So I'm going to start with that. I'm going to state, since those are same side interior, I'm going to say angle 4 and angle 5 are supplementary. My statement is not that those angles are same side interior. My statement is that they're supplementary. My reason, how do I know they're supplementary, is because they're same side interior. See how that works? Okay. So I'm just going to say that's the same side interior theorem. Because that's what it is. If R and S are parallel, those same side interior angles are supplementary. That's all we've got here. We've already stated that R and S are parallel. We observed that 4 and 5 are same side interior, so that means that they're supplementary. My reason is the same side interior theorem, which says if two lines are parallel, same side interior angles are supplementary. Okay, I'm going to make a move right now, and in a moment you're going to wonder why I made this move, and I'm going to explain why, okay? The next thing I'm going to do is to say, okay, if 4 and 5 are supplementary, well, then what does that mean? If two angles are supplementary, that means they add up to 180, right? So that's my next thing, is to say the measure of angle 4 plus the measure of angle 5 is equal to 180 degrees. Okay, this is one of those times where you're like, what's my reason here? Angle 4 and angle 5 are supplementary. Next one, 4 and 5 add up to 180. Stephen? Were you going to answer that? It looked like you were raising your hand. No? Robert, sorry. Robert, Stephen, you know. Okay, that's all right. Sorry, I threw you off there. This is one of those times where you're like, how do I know they add up to 180? Because they're supplementary, right? So when you get that really like snippy attitude about it, and you're like, because that's a definition. That's how you know the reason is a definition. That is the definition of supplementary. So that's my reason here. Definition of supplementary. I don't care if you guys abbreviate, as long as I can tell what you're going for. Okay, now here's the reason why I had to do that move. I couldn't just leave it at supplementary. I had to say they had to add up to 180. My next reason, I'm going to tell you what my next reason is first, because I think it'll help you to understand what's about to come. My next reason is going to be the substitution property. Can you imagine what I'm going to substitute here? Anybody want to take a stab at it? What am I going to substitute? Robert? Close. How about from this equation, what am I going to substitute here? Yep.
Maybe 5 and 7?
5 and what's congruent to 5? 6.
So what, 5 and 6 and 4 and 7.
Well, I can't substitute 4 and 7 yet. I don't know anything about 4 and 7. I know 5 and 6 are congruent. Okay. So I'm going to make that substitution. Oh no. Oh no. I wrote out this proof ahead of time to be prepared and just realized that I skipped a step. Substitution's not happening yet. Sorry. Okay, what I do need to do is say the measure of angle 5 is equal to the measure of angle 6. Do you see why? All I have so far is that the angles are congruent. I'm about to substitute measure of angle 6 for measure of angle 5. All I've got is that they're congruent. I need to state that their measures are equal so I can make this substitution. So that's just definition of congruent angles. Whoops, that's the wrong symbol. Congruent angles. Okay, we knew 5 and 6 were congruent. Their measures are equal. That's definition of congruent angles. Now I'm going to go back to this equation, and instead of measure of angle 5, I'm going to throw in measure of angle 6. And that is my substitution property. I really want to get up out of this chair and like go over there and talk about this. I feel like I'm like glued to the seat. Remember when I said that we were going to try to get a relationship between 4 and 6? Right? I started with a relationship between 4 and 5, and then I said 5 and 6 are the same. So now we're going to have that same relationship between 4 and 6. So now I've got the measure of angle 4 plus the measure of angle 6 is 180. We're kind of going backwards from what we did before. If their measures add up to 180, that means angle 4 and angle 6 are supplementary. And again, that's just definition of supplementary. Okay. If angle 4 and angle 6 are supplementary, are 4 and 6, are they same side interior for L and M? Are they? 4 and 6 are same side interior for L and M, right? If S is the transversal. Maris, what's up? Oh, thank you. Sorry, thank you. She's over there going like, 4 and 6 are same side interior for L and M. We've just said that they're supplementary. Theorem. If same side interior angles are supplementary, then the lines are parallel. So we have just stated that those angles are supplementary. We can now say that line L is parallel to line M. Okay, this is how we're using those theorems. This is one way. If we know that the same side interior angles are supplementary, we can then conclude that these lines are parallel. And my reason is just the same as it was up here. That's the same side interior theorem. Okay, so we have these theorems so that we don't have to write down that whole explanation. We don't have to write down if, 4 and 6 are same side interior for L and M. So if those same side interior angles are supplementary, then the two lines are parallel. We don't want to have to write that down every time. That's what the theorem says. Just state the theorem. That's it. Okay. Any part of that there where I lost you, where I need to do a better job of explaining? That was a very symmetric proof. See what I mean? It was like same side interior theorem, definition of supplementary, except for this congruent thing. Then we had our congruent substitution. Then we went back to definition supplementary, back to same side interior. Kind of, both sides kind of mirrored each other. That's kind of cute. Okay, I had to do this measure thing because we can only substitute into an equation. So one thing that I can see being a little bit confusing is somebody asking, hey, when you said 4 and 5 are supplementary, if I know 5 and 6 are congruent, why not just say 4 and 6 are supplementary? Well, the reason is because you can only substitute into an equation. So I have to take supplementary and make it an equation. then I can substitute into it. But that's why I had to say these measures are equal, because I only had them congruent. All right. We'll continue to do more and more of these, and you'll get more and more familiar with them. Okay, that's it. That's all I got. So, everybody say goodbye, period 7, wave, say goodbye, hello, bye, there you go, okay? And let's just say stop.